Okay, this is the other hardware architecture for pseudo round robin. Okay, this is the architecture figured out by one of my students. I will introduce his idea here. For the original pseudo round robin architecture, we have used 4 fixed priority arbiter, and he wants to reduce the logic area. So this is the start point of his idea. So how he make it? He just use one fixed priority arbiter, then at the collection point, he used 4 marks to select the right input request for each priority setting. That means we have 4 priority settings, yes. The second, the third, and the last one. Yes. Okay. So let's see some examples. For example, if this equal to 0, so the first character, the output here will be 0, yes. Request 0, and this will be request 1, yes. And this, the output of this max will be request 2, yes. Current priority is 0. Then the output of this max will be request 3, and he collects the output of the 4 max to the fixed priority arbiter. So this will just the same as the priority setting of this case, yes. You just look at this part, okay. Just look at part A, okay. And for if the current priority register is 2, okay, let's take 2 for example. So the output here will be this one, request 2. Yes, the here will be request 3. There will be 0, and will be 1. So this is just exactly the priority setting of this case. Yes. And feed the request to the fixed priority arbiter. So he do the priority setting using the 4 marks, and followed by one fixed priority arbiter. Then this part, okay, this part is used to trace back the ID of the original request. The 2 level of marks is used to trace back the ID of original request. So let's also use the 0 current priority equal to 0 example. Okay, and we assume the ID is 0 and the ground ID here is 1. That means this request, yes, actually the request 1 is get granted. So how to trace back? This is 1, so the ground ID will collect to 4 marks. 1, so there will be output 1, and this will be output 2. Yes, and this will be output 3. Ground ID is 1. The ground ID here is 0. Okay, it will output 0. Then he will use this marks to choose the write priority for this cycle. So 1 will be output here. Yes. So you can say actually the output of this mux. Yes, the output of this mux is the ID. Is the IDs of the input here when priority is 0, and the mux value here is the IDs. Yes, is the IDs of this of the input when current priority is 1. Yes. Yes, 你看 you see the first collection for priority equal to 1. Yes. And this is also the same for this one. The IDs here is the collection of the ID here for priority, for current priority equal to 3. Yes, when priority equal to 3, the first request, this request is collected to request, actually collected to request 3, and this request is actually collected to request 0, then the next collected to request 1, followed by this is actually collected to request 2. Yes. Okay, this is ideal. And if you are using this architecture, the alter code, yeah, the alter code will be different. Yes, yeah, the alter code will be different from the reference code here. Okay, that's all. Thanks.